Hello friends, I am Dr. Adil Khatri from MH Savasidi College of Engineering. I am an assistant professor in Department of Humanities and Applied Sciences. Today I am going to discuss something about determination of hardness of water using EDTA method. We know there are various methods for determination of hardness of water, and this is the most easiest way to determine the hardness of water. Now one such method is EDTA method. Now we'll see what is EDTA first. EDTA is ethylene diamine tetraacetic acid. Now this is having ethylene group, that is CH2CH2. This group is called as ethylene diamine. This is N and N. These groups are called as diamine. This is substituted by 4-acetic acid group. Okay. Now this type of compounds are act as a ligand, and these compounds are hexadentate ligands. Generally the solubility of this compound is very poor in water. It's not so good, so that is why it is used as in the form of disodium EDTA. Okay, now the disodium EDTA is used because its solubility is used, and as I already told you, it is chelating agent and it is used as disodium. Is that clear? Okay, we know that hardness of water is because of calcium and magnesium. Now this calcium and magnesium get binded with this ligand and form some type of this complex structure. This is your central metal ion, calcium or magnesium. We know that calcium and magnesium is having empty d orbital, and this are electrons which fits in the empty d orbital and form the stable complex. Is that clear? Okay. Now we'll move on to the titration. Now actually it is a kind of titration we do. Okay, so for any titration we know we require some indicator, and here in this case EDTA titration mostly used indicator is eriochrome black tea. Now it's actually a compound which contain an acidic group, and it is very dark blue color compound, but when it is diluted form it will form a blue color solution. Okay, now this indicator at the end point it gives blue color. Okay, how we'll see the chemistry behind it. Okay, now we know that as I told you that EBT is acidic. So for first this EBT forms complex with the calcium magnesium present in the water, that is hard water, but at the pH 10. Why pH 10? Because it is acidic. If the pH is not around 10, it will not form a good complex with the calcium and magnesium. So now we'll see what are the reactions involved in this. Okay, now we know that suppose we have some hard water and we have to titrate, or we have to see what is the hardness of the water. So what we'll do now, we'll see the sequence for how titration is done. Now this is your hard water sample, known quantity. Okay, let's say 50 ml or 100 ml or 10 ml, 20 ml, whatever. This is called as titrant. We know that in any titration chemistry, we know one is titrant and one is titrant. Titrant is which is filled in the burette, and titrant which is we generally take in the conical flask. Okay, now as I told you, you require buffer or pH 10, so some quantity of buffer is added to it, then EBT indicator. Now the complex of EBT and calcium magnesium from this forms a wine red color complex. Now this wine red color complex or solution is titrated with the known concentration of EDTA from the burette, known concentration of EDTA from the burette, and you will get the end point as blue color. Now we'll see the reaction here. That's very simple. Now reaction is, this is metal from the hard water, and this EBT is an indicator. Okay, few drops of this at pH 10, it forms wine red color complex. Now this wine red color complex is titrated with disodium EDTA from the burette, and as soon as all the metal get complexed with EDTA, this color becomes blue. Initially this complex was wine red, now it is blue. Now this is the indicator. That means our endpoint is from wine red to blue. Okay, this is our endpoint. This titration is done. Is that clear?